Hello everyone. So we are going to start now the part 6 from the topic Micromeritics. So in this topic we are going to deal with the packing of the particles present in a powder, some concept like fluidization and mixing of powder. So without wasting any time, let's start the presentation. So you see packing properties. Packing properties, it is also regarded as the porosity of the powder. So what do you mean by porosity? The definition of the porosity says that the porosity, it is the ratio of the volume of the voids. It is the ratio of the volume of the voids, means the amount of the void or the volume of the void present between the particle plus the volume of the pores, right? First of all, you have to add the volume of the voids, then volume of the pores to the volume occupied by the powder, means it is comparable. That is the summation of the two things, the volume of the voids and the volume of the pores divided by the volume of the powder including the voids and pores. This is the porosity of a powdered drug, right? Now you see a set of particles. If we have a set of particles, suppose the drug particles, it can actually be filled into the volume of space in defined way. Suppose we have 2 gram of a powder, we can fill this 2 gram of a powder in either a measuring cylinder or a beaker or a conical flask, and the thing is that after putting the powder, it will take the shape or the volume of the object where we have put it, right? So this is because these particles can be filled into the volume of the space in different ways, right? How it is going to fill? You see, this is because by slight vibration. If we put some powder in a measuring cylinder and if we do slight vibration, the particles present in the powder, they will be mobilized, they will be moving from one space to another space within that particle only, right? And thus they will occupy a different spatial volume than before, right? Earlier in a measuring cylinder, if we put the powder, earlier volume may be 100 ml. After tapping or after agitation, the volume may come to 90 ml. Similarly, in the conical flask, earlier it may have a cone-like structure at the top. After tapping, it will become a flap. It will have a flap-like structure at the top of the conical flask, right? So this change actually this change the bulk volume. Actually, the agitation or the shaking, it changes the bulk volume, as because the rearrangement of the packing geometry of the particles. I repeat, this change actually this change the bulk volume. The bulk volume, earlier it was 100, now it is 90 in the measuring cylinder. Now this change in the bulk volume, it is actually due to the change in the, or you can say, rearrangement of the packing geometry of the particle. Earlier the particle may be packed in a different geometry. After agitation, the particle will attain a different geometry. Clear? So in general, such actually geometric rearrangement, it results in a transition from loosely packed particles to a more tightly packed particle. Yes, of course, because if we agitate, if we tap the powder within certain object like your measuring cylinder or conical flask, after agitating or after tapping, the particle will be closely packed now, because the particle will try to occupy the voids or the pore space in between. So let's see their arrangement. So there are 2 figures, figure A and figure B. So these are the arrangement of the particles in the powdered form. You see, a set of the mono size means same size spherical particle can be arranged in different geometrical configuration, right? So let's see the first one, that is the figure A. Now here you see the spheres, actually they form cubic arrangement. They have formed the cubic arrangement, and they are in the cubic arrangement, they are loosely packed. So you can see the void space. These are the void space in between them. These are the void space in between them. So here the porosity, it is almost about 48%. Now in the figure B, you see they are arranged in a rhombohedral arrangement. They are arranged in a rhombohedral arrangement, and here they are densely packed, and the porosity is very less here. Just you can see here only there are porosity. So here it is almost half of that. It is 26%, right? So the porosity used to characterize the packing geometry and it is linked to the bulk density of the powder. So actually the porosity, it determines the packing geometry, right? If the porosity is more, then it may have a spherical arrangement. If the porosity is less, it may have a rhombohedral arrangement, and thus it control the bulk density of the powder. Clear? So you see the bulk density, it is nothing but it is the characteristic of a powder rather than individual particles. I repeat, the bulk density, it is actually characteristic of the powder. It is considered as a whole. It is if we have 2 gram of the powder, bulk density, it will represent the property of the 2 gram of the powder, not a single particle, because the individual particle can be arranged based on their tipping, based on their object in which we have put that powder. Clear? Next thing is that the bulk density of a powder, it is always less than the true density of its component. Why? The bulk density of a powder, it is always less than the true density of the component, because the powder contains interparticle voids. I repeat, the bulk density of a powder, it is always less than the true density, because the powder, it contains interparticle voids. Clear? Thus, lastly, you see, the powder can possess a single true density. It will have only a single true density after tapping, right? But it can have different bulk density, which depend upon the object in which we have placed the powder. Actually, it depends on the way in which the particles are packed and the bed porosity. Clear? The next thing, it is the powder fluidization. So we know what is powder fluidization. It is applied with the help of air generally to make the particle or to increase the fluidity of the powder. So fluidization, it can be highly effective for handling the fine bulk powder in the aerated, or you can say liquid-like condition. Why we need this actually? The fluidization, it is helpful in preparing the powder for compression, for formation of the tablets. So air or another gas can be used for fluidization, either in the fluidized state or in a localized manner with a small quantity of the gas flow. So generally, you just for fluidization, you just consider the example of FBD, fluidized bed dryer. In FBD, we generally use the granules, but if you directly want to fluidize a powder, then in the FBD you can use the powder itself without formation of the granules. So the typical bulk solids actually suitable for fluidization have fine particle size, low permeability, and low cohesive strength. I repeat, a typical actually bulk solid which is suitable for fluidization. Which type of solid you can use for fluidization? Which have a fine particle size, right? Which have a low permeability and a low cohesive strength. Means agglomeration will not take place in a fine particle. Clear? So what are the advantages of the fluidization? Fluidization, we used to do it before the compression that is used for preparation of the tablet. Advantage: reduction of the pore flow problems of the powder, means to increase the flowability of the powder. Actually, it increases the discharge rate from the hoop part. If we do the fluidization, it increases the discharge rate of the powder from the hoop part. It will lead to the free flowing powder from the hooper to the die, and thus it will enable a proper compaction of the powdered drug for preparation of the tablets, right? Next advantage, it is the reduction in the mixture segregation. Sometimes segregation of the mixture takes place, means the drug will separate out, the excipient will separate out. If we do proper fluidization, then the mixture segregation will not take place, means all the drug and additives will be mixed together, they will come close with each other, right? And actually it increases the gas solid interaction for drying. If we do the fluidization, it will increase the interaction between the gas and the solid, right? It will help in the drying. If we perform the wet granulation process, in the wet granulation process we used to have some solvent for granulation. If we do this powder fluidization, that solvent can be removed out. Right? Now the next thing is the powder mixing. So the importance of the powder mixing, why it is important? Number one, the pharmaceutical products, we know that it has several ingredients. Because in a pharmaceutical product, suppose we have prepared a tablet or any granules or any suspension powder, whatever it is. So what we are going to do? First of all, we are going to add the drug, right? Then we are going to add the excipient. The drug as well as the excipient, they will be in the powdered form. So if we do a proper mixing, it will help in the formation of a proper mixture for preparation of the dosage form. So pharmaceutical product, we know that they have several ingredients to formulate for the required dosage form. Example, tablet. In the tablet, we have many excipients like diluent, we will have binder, disintegrant and lubricant, right? So whenever a product contains more than one component, right? For example, your tablet, the mixing or blending, it is very much essential. Why it is essential? For even distribution of the active component for uniform drug distribution. Even distribution means the API, the drug should be evenly mixed, should be mixed properly for formation of uniform dosage form or uniform drug distribution, and this will lead to the release of the drug from the dosage form, for example tablet or capsule, at the desired rate, and even for suspension for a even appearance. For suspension it will appear clearly. Thus the mixing, it is very much essential. Clear? So mixing, we know that pharmaceutical mixing, it is nothing but it is by virtue of definition, it is a operation actually. The pharmaceutical mixing, it is an operation which helps to bring each of the component as near as possible. Means the drug along with the excipient, we will try to bring them close as possible, right? So if this is achieved, if we can do that, then we generally use a theoretical term, that is the ideal situation. Or ideal situation, it is also known as a perfect mix. Clear? So thank you everyone for your patience hearing. If you like the video, just press the like icon. You can share this video and you can subscribe to my channel. Thank you once again.